In the previous video, we discussed about Buckingham's Pi Theorem and problem solving. We started a solving of a problem and where t is depending on d, n, mu and rho, and we determined two pi terms or dimensionless terms. So first pi term is d power n1 a1, n power b1 and rho power c1 into here t is there, and for pi 2 it is d power a2 is the first repeating variable, n power b2 is the second repeating variable, rho power c2 is the third repeating variable, and here the remaining thing is mu, dynamic viscosity. Now if I am going to write the dimensions for these first particular things, that is for first pi term, pi 1 is equal to d power a1, n power b1 and rho power c1 and t. Here for pi 1 there is no dimensions, hence dimension for pi 1 is m0, l0 and t0. Dimension for d is l power a1. For dimension for n is t power minus 1 power b1. Dimension for density is ml power minus 3 power c1, and for torque it is ml square t power minus 2. Now we are going to compare the power of mass, length and time. If I compare the power of mass, 0 is equal to c1 plus 1, so c1 is equal to minus 1. If I compare the power of length on both sides, 0 is equal to a1 minus 3c1 and minus plus 2. So 0 is equal to a1 minus 3 into c1 is minus 1, so plus 3 plus 2, so a1 is equal to minus 5. Then comparing the powers of time on both sides, if I compare the power of time, 0 is equal to minus b1 and minus 2. So b1 is equal to minus 2. Now what I am going to do is, I am going to use these values of a1, b1 and c1, I am going to substitute it here. So pi 1 is equal to d power a1 is minus 5, n power b1 already we calculated, which is minus 2, then rho power c1 is minus 1 and t as usual I am putting here. So this pi 1 is equal to t by d power 5 n square rho. Now I got the value of first pi term. Similarly, we can calculate for second pi term also. Second pi term pi 2 is equal to d power a2, n power b2, rho power c2, and here it is mu. I am going to write the dimensions m0, l0, t0, l power a2, then here it is t power minus 1 power b2, this is ml power minus 3 power c2, and dynamic viscosity is ml power minus 1 t power minus 1. Now I am going to compare the power of mass, length and time on both sides. If I compare the power of mass, 0 is equal to c2 plus 1, so c2 is equal to minus 1. Compare the power of length, 0 is equal to a2 minus 3c2 minus 1. If you use this, a2 plus 3 minus 1 is plus 2, so a2 is equal to minus 2. If you compare the power of time on both sides, 0 is equal to minus b2 minus 1, so b2 is equal to minus b2, that is t is equal to 0. Here the power of t is minus 1, minus b2 minus 1, b2 is equal to minus 1. Now what I am going to do is, I am going to use this a2, b2 and c2 on these values. So pi 2 is equal to d power a2 is minus 2, n power b2 is minus 1, rho power c2 is minus 1 and mu. So pi 2 can be written as pi 2 is equal to mu by rho n d square. Now I got the values of pi 1 and pi 2. So t by d power 5 n square rho, which is equal to mu by rho n d square. So t is a function of d power 5 n square rho, comma, or mu by rho n d square. Thank you.